Welcome to this tutorial video for tips and tricks on solving certain algebra equations. In this video, we will cover solving inequalities. I will show you when it's important to remember to change the sign, solving and graphing absolute value inequalities and writing the answer in set notation, as well as we're going to learn about parent graphs for certain translations. We're going to start with solving inequalities. Whenever you solve an inequality, you can treat it the same as you would treat any equation. And instead of using an equal sign, you just keep the inequality. So for this one, for example, we'd start by adding 3 to both sides. That would leave us with negative 4x is less than negative 8x. And this is where it's important. Anytime you divide or multiply both sides of an inequality by a negative number, you must flip the inequality sign. That's very important or you'll get the whole problem wrong. So for example, we now would divide both sides by negative 4 to isolate x. Well, since we're dividing, also if we multiply both sides of an inequality by a negative number, instead of the inequality symbol staying the same, it switches. So less than becomes greater than. So now you have x is greater than, this x wouldn't be here. X is greater than 2. So you see, you have to remember to switch the sign anytime you multiply or divide by a negative number. That's extremely important. And sometimes the software that you use does not teach you that. So it's important to remember that. Also, with absolute value inequalities, you always want to isolate the absolute value first. So for example, the absolute value of 3x plus 2 minus 2 is greater than or equal to 0. Well, the first thing we have to do is isolate this absolute value so it's the only thing on one side of the inequality sign. So what's standing in the way of the absolute value of 3x plus 2 being all by itself? Negative 2. So we're going to treat it just like we would any equation, and we're going to add 2 to both sides. So now we have the absolute value of 3x plus 2 is greater than or equal to 2. Now that we've isolated the absolute value on one side, now we can make 2 inequalities. So what you do is you write the first inequality exactly as it is, just remove the absolute value signs. So 3x plus 2 is greater than or equal to 2. Then you write it again. But this time you flip the sign. So the inequality symbol flips. And whatever's after the inequality symbol changes sign. So since 2 is positive, it now becomes negative. So we did 2 very important things here. First, we had to flip the inequality in the second equation. And whatever followed the inequality, we had to change the sign. So if it was negative, it would become positive. In this case, it was positive, so it became negative. Now you can just go ahead and solve both equations as you normally would. So you could subtract 2 from both sides. So 3x is greater than or equal to 0. So same thing over here. You would just go ahead and solve. Okay? So let's just say that our answers turned out to be, let's say x is greater than or equal to 2 and x is less than or equal to 6. Now we have to graph those. Now sometimes you'll be required to graph them. Sometimes you won't, but I suggest always graphing them, at least in your mind. So on a number line, and you only need the actual x number line. You don't really need the y. So we have 2 and we have 6. So here's 2 and here's 6. So now whenever you have x is greater than or equal to, these always use brackets or closed circles on a graph. Whenever you just have greater than or equal to, greater than or less than, I mean, that uses parentheses or open circles. So since these have the or equal to, we know we're going to use these. And I would suggest using the dots on the graph. So these are, if you noticed, a closed dot on 2 and a closed dot on 6. You always read inequalities from left to right. So in this case, x is greater than or equal to 2. So that means everything to the right of 2 is greater. But x is less than or equal to 6. So everything to the left of 6. So which parts overlap? This would keep going, obviously. This would keep going. So the part that overlaps is right in between. So you would color this part in. This would be a closed dot and a closed dot. That would be your graph. Now we have to come back to these symbols for set notation. So we need to express the fact that the solution set is everything between these two closed dots, which represent 2 and 6. So what we're going to do is we are going to use our parentheses, our brackets, and we are going to say that 2, 6, and that would be our answer. That says the solution is everything including 2 and including 6 and in between them. Okay, and that would be the solution set for your answer. All right, you could also do each individually if they didn't want you to give an answer for both. So for example, for this one, which is x is greater than or equal to 2, your solution set would just be 2 to positive infinity, and infinity always gets a parentheses. For x is less than or equal to 6, you would do negative infinity, comma 6, bracket. So these would be the answers to each individual equation. And then when you put them all in the same graph, you would get this answer here. Okay, so we're going to change gears a minute, and we are going to talk about parent graphs for translations. Translations are a very important part, definitely of pre-calc, but it's good to have an idea of them in algebra. Okay, now a parent graph would be a graph that is pretty standard. So for example, this is the parent graph for x squared. Whenever you have y equals x squared or f of x equals x squared, you know it's going to be a parabola that opens upward, and the vertex of the parabola goes through 0, 0. And obviously these arrows go to infinity. For absolute value of x, it's very similar in that it still has a vertex at 0, 0, but it's more of a V. For the square root of x, it's kind of like a parabola turned to the right where the bottom half is erased. So it starts at 0, 0. That is your anchor point. And then as you can see, it continues up and to the right to infinity. And the reason I keep saying about the vertex or the anchor point is because that's the point you will use to move them when you translate. Because obviously, all through this curve, you don't know exactly what number you're on, but at the anchor point, you know exactly. So it's very easy to manipulate the graph to translate it from that point. That's why it's called an anchor point. Y equals x cubed. Now, again, 0, 0 is your anchor point. This is kind of like a regular parabola, except the left side is flipped down. And these, you're going to want to memorize these. For an exponential function, which you may or may not see in algebra, it's sort of like a parabola, but a little different. And the anchor point in this case is 0, 1. That's very important. You have to remember the exponential function graph does not go through 0, 0 like the rest do. And finally, the inverse, and this one's very difficult because it doesn't have any real anchor point, but you probably won't see that right now. Now, just very briefly, I want to say that when you do these translations, let's say you have y equals x squared plus 2. The plus 2 would mean up to. So you would basically take your x squared, and instead of drawing it where it goes through 0, 0, x squared plus 2, the anchor point moves here, and it's the exact same graph otherwise. Do you understand? And the same if it's minus 2, it would be down 2. Okay? Now, if you have y equals, and in parentheses or brackets or any grouping symbol, and by grouping symbol, it can be parentheses, brackets, it can be absolute value, it can be a radical. If there's a grouping symbol and you have it like that, and it's within the grouping symbol, now, instead of up or down, it changes to left or right. And whereas with up or down, it goes with the sign, by that I mean positive goes up and negative goes down. When it's in a grouping symbol, it goes left or right opposite the sign. So a plus 2 would actually be left 2, and a minus 2 would be a right 2. So again, you would start with the same x squared graph that goes through 0, 0 with the vertex, and you would move that vertex for the top one here 2 spaces to the left, for the bottom one 2 spaces to the right, and redraw your parabola. That's the main thing you have to remember. Now, if you have a negative in front of the x squared, it's the same thing. That would be your parent graph, okay? But the negative means it opens down, so it literally just flips it, but it still has the same anchor point, okay? And you'll see different combinations. You may see a negative in front of a grouping symbol, or you may see a negative just in front of the x squared in general, but it may still have a plus 2. So in which case, if you had something like, now this would be a parabola that opens down, and instead of going through 0, 0, it would go through 0, 2. So it would look something like this. And like I said, it's best that you memorize these, and there are a few more that you might want to look up. So if you go on Google or YouTube and you look up graphing translations and parent graphs, you'll find all this. But when you take a test, you're going to be expected to have the parent graph memorized. And when it comes time to do the translations, you have to remember all the little tips and tricks that I just showed you, plus possibly familiarize yourself with more based on the instructor you have. I hope you found this helpful for some tips and tricks in algebra, and I wish you luck in all your classes.